And welcome viewers, friends, and foes to the Daily Space Weather. An exciting series of massive coronal mass ejections have occurred. One of them likely does have a slight Earth-directed component. Check out the northeastern limb up here. You can see this massive bit of plasma, very dense plasma, escaping the solar corona here first thing this morning on May 5th. It's an exciting time for space weather here at the Smash News Network, least busted name in news, and we are delighted to bring you yet another daily space weather video. It's just the most comprehensive daily space weather and detailed solar imagery you'll find in the known universe. This is the last 24 hours of SDO 304 plus 193 angstroms. Again, all eyes on the northeastern limb up there. It is just spectacular. Watch this plasma. Whoops. See you later. That was a very dense plasma filament, leaving the solar corona much intact. And that is not the one with the earthly directed component. We will get to that later in the video. It'll be a minor Earth impact, probably no higher than a KP 6.33. Here's just the northern polar region. See yesterday's daily space weather video for an insane CME coming out of the North Polar Crown Prominence area. A huge spiral-shaped CME. Just a massive series of CMEs happening since yesterday. We'll show them. First, the western equatorial limb. There is still some possibility of decent-sized flares from the western limb. The most likely spot continues to be the northeast, though. A huge conflagration of sunspots recently showing up there. There's a well-defined coronal hole in the southern hemisphere. We do have another small sunspot forming. We've got an uptick here in most solar parameters. By the way, that CME impact, we're expecting that to show up late in the day tomorrow, the 6th. Possibly as early as that, or maybe even as late as midday on the 7th. So sometime between late day the 6th and midday on the 7th. There is the eastern equatorial limb. And let's talk about sunspots. So we do have this new group that just rose right here. This sunspot down here has looking like it's evaporated here. The rest of these are stable, and there may be a new pore forming or rising down here in the southeast. Here's colorized magnetogram. These images depict yesterday plus today. And let's see what's going on around planet Earth. So here's our volcano rundown. We show it daily on the channel. Luitolo is erupting, producing a 6,000-foot ash plume over the Lesser Sunda Islands. Semeru producing a flight level 150 as it explodes on East Java, Indonesia. It's a 15,000-foot ash plume. 28,000-foot ash plume in central Mexico from Popocatépetl. Looks like an uptick there at Popocatépetl. Flight level 280. Fuego, flight level 170 over Guatemala as Fuego explodes. Nevado del Ruiz exploding, flight level 190. Flight level 240 over Cotopaxi in Ecuador. It's a 24,000-foot ash plume, and not sure if Sabancaya is erupting or not. We'll get to earthquakes here momentarily. There is the last 90 days of seismic activity. There was one decent-sized quake in the past 24 hours, a 6.2, which we will get to here in a moment. First, please take a moment to support the channel. If you haven't seen the links below the video, one of them is a link to our Hemp Lucid shop. The most popular products are the CBD oil and tinctures. You may be familiar with them, or maybe not. Perhaps get yourself familiar with them, as these are for all sorts of different things. So there's the CBD full spectrum hemp seed oil tincture, the water-soluble CBDs, natural flavor, orange flavor, mint flavor, etc. If you haven't tried those out, check them out. If you want to check out any Hemp Lucid products, don't forget to enter the promo code SMASHOMASH to save some dough on checkout. This is the paid promotion that you do see highlighted in this video. So check out the links. You can find them on the homepage as well as below this video in the description. And if you're viewing the videos on BitChute, make sure you go subscribe over on YouTube. You're missing probably over 90% of the content at this point. Today's featured product is something Hemp Lucid is doing. Mensa, Make Earth Not Suck Again. Now, these have made it all the way around the planet to Tasmania. Shout out to Dirk for picking up some Mensa products. Yeah, all the way in Tasmania. Yeah, our products have crossed the equator. This is our third bestseller, by the way. And I've got some of the products myself. I've got my own Mensa hat. As part of the purpose of the channel is to make Earth not suck again. Since it is up to you, this is a message of personal responsibility. Make Earth not suck again. It's up to you. And feel free to hit up smashomash.org, which will redirect you to our .com. As we are in the process of founding a science foundation, it's been taking a little bit of time here as a result of things like economic downturn. So support the channel via some merch products. Links below the video to the Redbubble shop as well. And here's the largest quake that we talked about over the past 24 hours. Again, it was a 6.2 right off the coast of Japan. So there is a location of that. That 6.2 came in at 5:42 Universal Time this morning on Cinco de Mayo. So we'll scroll up the rest of the list here, citing quakes over a 5 magnitude. Some quakes in the southern part of the U.S. there, but the most American quakes were around Alaska, mainly the Aleutians and the Alaskan Peninsula. We'll cite quakes over a 5 magnitude like this 5.1 at the Solomon Islands. That was at 22:20 Universal Time yesterday evening, that 5.1 magnitude quake. So only a few quakes over a 5 magnitude here. There was that 6.2. That looks like it came through with no warning. 6.2 there at Honshu, Japan. That was at 5:42 this morning. One of only 2 5 magnitude quakes in the past 24 hours. It's been pretty calm. Let's get back to space here, as there is plenty going on there. You can see that CME happening right there, that very, very dense plasma filament. That might be the densest plasma filament we've ever featured on the channel. It is indeed quite spectacular. We've got some close-ups for you a little bit later in the video when we talk about coronal mass ejections. Let's move on to some more stats here. The 10.7 centimeter radio flux is now at 162 solar flux units. And that radio flux comes from the upper chromosphere and the lower corona. This thin layer in between the photosphere and the corona, the chromosphere, the upper part of that, and the lower atmosphere or corona are where the 10.7 centimeter radio flux come from, discovered back in 1947. And we've been monitoring that ever since it's a directly proportional data set to sunspot number. It's the vibrational frequency of hydrogen. And of course, it puts out more radio flux when it is an active sun. So you can see there's the black line is the 10.7 centimeter radio flux. The red line is the sunspot number. Actually had a little dip in the sunspot number since yesterday, as there are some setting regions in the west. Now, as far as NOAA forecasting CMEs, they're forecasting, looks like a complete mist to the west and south. So that's the Space Weather Enthusiast dashboard. That's NOAA's forecast for the CME. It looks like Earth will just be missed there. That's sort of a wishy-washy forecast, in my opinion. I think part of that CME will actually hit Earth. Again, we're not expecting more than a 6.33 for the KP index from that. We are expecting that to show up sometime between 1500 tomorrow on May 6th and 12 noon on May 7th. It might last for a while there. It might last as much as 12 to 16 hours, but I would suspect it'll be rather short-lived. I think it is just a glancing blow. It might be a little more direct than what NOAA just forecasted there, but anyway, expecting a minor CME impact late in the day tomorrow, as it did look like it was high speed. We'll also show NASA's forecast which does not have this modeled at all. So this might, I expect this to probably be upgraded later today, as we've only got a far side CME there showing up. So anyway, that should be updated today. You heard our forecast. Let's take a look at some stats here. Here are the past 4 hours of Earth's magnetic moment from space. So this is depicting magnetohydrodynamic pressure. We show it daily on the channel. People are very spooked that Earth's magnetic poles are going to flip. I am unconvinced. Unconvinced. As we don't see evidence of it in a lot of places where we should, if Earth's poles were in the process of flipping. Here's Earth's magnetic moment from the ground, which makes it even more obvious that Earth's magnetic poles are very unlikely to reverse. This is depicting magnetic flux density at the ground level, and things are geomagnetically calm here. Now, we may have seen a small CME impact. I suspect we probably did. In fact, it might even be two of them. Or it could be the same cloud showing up twice, as those clouds can be irregularly shaped. We'll get to that in a minute. First, the KP index, which is at 1. KP1, geomagnetically calm conditions. For you new viewers out there, the KP index is an average of global geomagnetism. Next, we'll go to Lagrange point 1, where the real-time solar wind is measured well outside of Earth's magnetosphere. And there's the current situation. So we do see these variations happening here. There was something that looked like a tiny CME impact yesterday, which is right about when we forecasted the CME impact. Right about there, you can see the plasma temperature changes, also the speed and density change, and there are minor changes in the field. And then early this morning, we saw another minor CME impact looking situation right here. Once again, the magnetic fields changed, the solar wind density changed, and the speed, also the plasma temperature. So it looks like two minor CME impacts. Those were not associated with a strong magnetic field. If they would have been, we would have seen a KP 5 or 6 perhaps, but the fields were pretty weak and not particularly strong in the negative BZ territory, which is this top red line here. A strong negative BZ signal, along with a strong field, means geomagnetic storm conditions. At the moment, certainly not. We've got a BT of only 4 nanotesla and a BZ of -0. -0, folks, yeah. For all you mathematicians out there, that should offend you. For that, we apologize. Current conditions are solar wind density just over 2 protons per cubic centimeter. Solar wind speed here about 438 kilometers per second. GOES magnetometers here showing a little bit of spiky readings there, as there were some plasma variations happening, so that'll tend to cause some variations in the magnetic field as electrons are accelerated in things like the outer Van Allen belt, for example. That does affect the fields. Those are the GOES magnetometers for the past 3 days. And let's switch to the heliospheric current sheet. So Earth is in a North Pole current sheet, almost right in the middle of it here. No changes expected anytime soon. Just keep in mind the magnetic environment can change suddenly and with no warning. Continuing on to our line of sight field plot, you can see the B field in blue here all fanned out, as Earth is right near the middle of the North Solar Magnetic Pole. Welcome to the North Pole. And let's move to coronal holes, since we've got a high-speed coronal hole wind stream coming soon as well. So here we've got a lot of North Pole-oriented coronal holes, including one at the North Heliographic Pole. We're waiting for that to leave so that we can say, hey, we're approaching solar maximum. At the moment, it's just not the case yet. There's the latest image. And let's switch to our coronal hole wavelengths. So now you can see coronal holes in 171 angstroms, especially very well-defined ones, as you can see here. These are pretty well-defined coronal holes right in this area, and they are of North Pole orientation. And here's 211 angstroms. This coronal hole is North Pole as well. So we are expecting a coronal hole high-speed stream impact from this coronal hole, and I mean, we could get some impact from this one as well. So this could be a long duration coronal hole high speed stream here once again, and could be high speed too. So we'll see what happens. We can expect about 2 days for that to arrive as well. So we may have a co-interactive region here, which is when you have a coronal hole and a coronal mass ejection arriving around the same time. That plasma can interact with the other plasma. And let's get to sunspots next. So here's a sunspot situation. There may be one new named group down here. That'll be 3299. If it gets a name, we'll take some high-res imagery of that toward the end of the video. Just before we switch to our meteorology segment, and let's take a look at sunspots. Here's your SDO magnetogram for the past 24 hours. And let's zoom in a little bit closer here to the northeast, since that is where it's at. All the exciting action happening up there. And we're going to switch to 1600 plus 1700 angstroms to show some additional detail here. So exciting stuff there. And it's time to look at energetic particles and solar flares. Ever heard of solar energetic particle events? That's when you see a big spike in the proton flux. When that happens, you've got protons encircling the magnetic field lines, and it starts around the poles that causes polar radio blackouts when we have significant proton events. At the moment, just 2 little tiny spikes back here on the 3rd. And we did have another long duration M-class flare, just as we did show prep this morning. It was an M2.1. Peak flux was right around 8 o'clock this morning. And let's take a look at our flare wavelengths. Not surprisingly, that M-class flare came from this sunspot group up here in the northeast. It has certainly been the largest flare producer for the past couple of days. That CME launching like a rocket up there. Great absorption feature, and you can see plasma splashing back down after it exits also. A common thing is when CMEs happen, some of the plasma often splashes back down toward the chromosphere and creates secondary flaring effects, as you can see there. A lot of material forced to take a vastly different path as the magnetic field lines reorient and the plasma exits the solar corona. Next, we're going to get the CMEs here, but first, let's take a moment to take a look up. So that's what's going on overhead over Lehigh Valley, Pennsylvania. And you should consider becoming a member of the Smash team at the silver or gold level. We put up a post about that. If you haven't seen all of our videos, you might not know about some extremely interesting events coming, like great viewing of Venus in the evening sky. I believe Venus reaches its peak on the 14th. Again, join the Smash team at the gold or silver level for more information about some spectacular astronomical events coming in the month of May. Next, we're going to do a solar system forecast here. I don't like to repeat myself too much on the channel, so we just provide a certain amount of information, perhaps just the right amount. Anyway, here's your solar system forecast, as we've got terrestrial planets on one side and gas giants on the other. Here's where things will be on May 12th. We will still have a gibbous waning moon by the 12th of May. Now, let's continue on to CMEs. It's been exciting, and this imagery will depict the likely Earth-directed CME. It happened before noon yesterday, and there was like a delayed halo happening there. I believe it's because that halo needed to traverse the sun. It's a great example of how a CME way up near the northeastern limb can indeed have an Earth-directed component. I mean, keep in mind, you're only looking at a 2D map here, and with stereo A as close to the Earth as it currently is, it can be a little bit tough to figure out the trajectory of CMEs. Anyway, that's yesterday's imagery, and you'll see right at the beginning, right about here, you can see a halo coming out. That is associated with an M-class flare and a CME in the northeast. Anyway, those are yesterday's frames. We'll also show this morning's frames since they are indeed spectacular. That massive CME popping off once again in the northeast. That one looking very unlikely to have an earthly directed component. Let's take a look at that CME from this morning. We're even going to slow that down since it's only a few hours. Check out that launch. That is fantastic. It's there, and whoops! Now it's out of there. How you like them apples? And thanks for leaving a comment, Robert and John. So yeah, that's pretty sweet, right? Here are some custom Helios viewer coronagraph images. Oh, first our LASCO coronagraphs. All right, so let me bring these back. Actually, we're gonna let those play through here. So right at the beginning of that is the CME that likely has an earthly directed component. After that, the rest of those I don't suspect have earthly directed components. We don't really see any other halo eruptions. But let's make sure. We'll look at stereo A as well to give some, at least a little bit of additional angle. All right, so we have these paused here at 9:23 Universal Time for stereo A's coronagraph on the left and 11:18 Universal Time for the Soho LASCO C3 on the right. And let's just slowly advance this. Now you'll see this CME coming out of the western limb there. And then kind of at the end of it, you'll see a halo-like eruption. That is a separate event from the North Crown Prominence eruption that we covered yesterday. Right there, you can see it as well. That halo-like eruption, that is part of this cloud coming out over here, not this part. So it looked like three. We thought it was originally three events yesterday, but it looks like it's only two. The Crown Prominence eruption, and then that M-class flare-associated CME from the west. I think the one from the west does have an earthly directed component. So we'll let these play through here and then show some custom coronagraphs. Another fantastic bubble-like eruption. So lots of CMEs happening here in the past 24 hours. And these are 24-hour videos here, so yowzers. Those are indeed quite the display there. A prime example of how you don't need to see large flares to see massive coronal mass ejections. Let's go one step closer. Yowzers. That is some compelling imagery indeed. All right, so let's move on here to look at filaments, as the likelihood of additional CMEs in the earthly vicinity remains. There are still some very well-defined filaments. You can see them here as dark absorption features overlapping the solar disk, or as prominences, which look bright as they hang off the edge of the solar disk. So we've got at least three rather well-defined filaments, one down here in the southeast, one right in the central portion of the solar disk. Let's hope that ejects today and heads straight toward the Earth. and there's one up in the northwest. A lot of people are frightened of CMEs. We hope you're enlightened by CMEs instead. Good stuff. All right, so let's continue on. We have one more series of images here. Here is your GOES. Is it the GOES 18? Back to the GOES 16 SUVI. So that CME up in the northeast just got done propagating here. We actually streamed the beginnings of that earlier on the YouTube channel. And we've been doing extended YouTube live streams because, well, people like you probably like it. Anyway, continuing on to our bonus feature segment, we've got satellite charging hazards once again. Some significant internal charging hazards here over the southern Indian Ocean, Western Australia and Oceania, places like Indonesia and Papua New Guinea. Also the southern Atlantic there, seeing some internal charging hazards as high-energy electrons get inside of the internal circuitry of satellites. It could cause some communications errors. Here's your GOES electron flux. These are measured at the F layer of the ionosphere. And we got up to like 6 times the warning levels yesterday, a little bit higher than expected. So because we were expecting a more significant CME impact, we didn't really get that. Electron flux levels have remained on the high side. We are expecting a precipitous dip in this, certainly when the coronal hole high-speed stream shows up, or when a CME shows up, and NOAA looks like it agrees here. That's the relativistic electron forecast model. The green boxes are the forecast. The yellow diamonds are the observation. There's the one-year graph to put it in context here. We're expecting to come off of these highs. As we came off the longest extended low, and now we're coming off the longest extended high of electron flux for the entire year. Those are measured at the F layer of the ionosphere, so we'll show the vibrational frequency. Feel free to pause the video on this frame if you're not familiar with things like electromagnetic radiation penetration through atmospheric layers, temperatures, and chemical concentrations. Here's the courtesy of Australian Government Bureau of Meteorology ionosphere data. The diffuse gas in the bridge between Earth and space is vibrating, and this data shows you the vibrational frequency, which is typically the highest around the equator at noontime, as the thermosphere is hotter as you go farther out into space, unlike the troposphere, which is warmer at the surface. Yes, Earth's atmospheric layers have temperature inversions, layer after layer. That's why the stratosphere is warmer at the top than it is at the bottom. Anyway, if you're not familiar with that data, don't worry. We show the anomalygram as well. So here's the anomaly from the 30-day median. In megahertz, it does show you 10 times as much resolution here, as it's showing the anomaly to 1/10 of a megahertz as opposed to integer megahertz shown in the raw megahertz data. Ionosphere continuing to settle back down, although still quite a lot of low-frequency anomalies here showing up, as it is still somewhat puffed up for over a week following a very strong geomagnetic storm, which we covered. See our earlier space weather videos for that if you haven't. We're pushing 6 years on doing daily space weather. There's the latest image. That's 11:15 Universal Time ionogram at 11:30 Universal Time anomalygram, for whatever reason. We'll also show the total electron content forecast. That'll show the free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with those distances. Here are the most likely places to see GPS errors. That is depicting the free electrons to the inner portion of the outer Van Allen belt through the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and Earth's ionosphere. Those free electrons can cause your signal to be refracted. I've seen GPS errors of several hundred miles I did a bike ride one time where my average speed was calculated to be 10,500 miles per hour. I don't think I was going quite that fast. Incidentally, I didn't melt in the atmosphere, so that's an indication I probably wasn't going 10,000 miles an hour. Anyway, here are the latest intensitygram and colorized magnetogram for you. Let's see if we have a new sunspot down here. And I do see a pore there, so that could be a new named sunspot group today if it remains in the solar disk for more than 12 hours. We'll expect that to get a name. Also, I believe this group here will get a name. We may see a continued uptick in the radio flux as well. Also, possible increase in the sunspot number, as we'll have at least 2 more named groups possibly showing up today. So that brings us to our meteorology segment. And let's do it. Let's do it. I'm excited. Our meteorology segment is going to start out with sea surface temperature anomaly. Yeah, sea surface temperature anomaly. So why are we looking at this? Well, that's Earth's largest surface heat sink. Yeah, there's a lot of heat contained in Earth's surface water. A lot more heat, like 99% of the heat on Earth's surface is in the water, not in the atmosphere, as water has a really high latency of heat and air not so much. Now, if you think mankind is able to heat up and cool down the Pacific Ocean, I feel sorry for you. You have reached the height of human ignorance and arrogance. Mankind is not capable of controlling large-scale weather patterns, the temperatures of the ocean, and hence the climate. If that's too controversial for you, I don't know what to tell you. Those are just facts. But that's the sea surface temperature anomaly for the Pacific Ocean, Earth's largest surface heat sink. And fun fact, if you don't know the temperature of the water at 1,000 meters over here, and at 300 meters over here, and at 1,000 meters over here, you don't know the Earth's climate, period. Here are the sea surface temperature anomalies of the Indian Ocean, sea surface temperature anomalies of the Southern Ocean. The animation you see there is surface winds, by the way. How about the sea surface temperature anomalies of the Atlantic? There you go. Sea surface temperature anomalies of the Arctic. And let's take a brief look at the Gulf Stream. So there's a Gulf Stream, a bunch of warm water mixing it up with a bunch of cold water there. And it looks like indeed some snowmelt waters are making their way down there from the Beaufort Gyre and so on. Bunch of cold water there around the coast of Greenland. That is your sea surface temperature anomaly breakdown. And let's get to our regularly scheduled meteorology. Here is the surface wind scenario for the eastern world. Here is the jet stream scenario for the eastern world. Here's the jet stream scenario for the Americas. Huge backward jet stream here over eastern Canada. Surface winds for the Americas. Surface winds for the central world. And these are the jet streams. The best indicator of global weather patterns, the jet streams, depicted here at nullschool.net as the 250 hectopascal winds. Next, we're going to show clouds and fog over the Americas. So there are the data from the NASA GOES Interactive Weather Satellite Suite. That wavelength is 3.9 micrometers, part of the infrared radiation spectrum. It'll show clouds and fog at nighttime when it's too dark to use the visible satellite. And let's switch to our weather.gov map. So here we are, weather.gov. If your location is lit up, click your location on weather.gov. There are the keys to show you what those color codes indeed mean. I've got some frost advisories here in western PA, parts of Virginia, Maryland, and West Virginia. That brings us to our forecasts. Here's the GFS 72-hour pressure and precipitation forecast. as some heavy snows are forecasted to show up in California and Nevada especially, well into May. Of course, temperature anomaly is also going to be an issue, so let's cover that. There is your temperature anomaly forecast based on the same GFS 72-hour model. Keep in mind it is in degrees Celsius. We've got some more seasonal temperatures and some slightly above average temperatures coming to the mid-Atlantic states. And if you are thinking on going on a cycling vacation, why not join us in Lehigh Valley, one of the largest cycling communities and some of the best roads and trails in the known universe. Next, we'll take a look at snow depth here. Snow depth, there is still a lot of snow to melt. That's the point I'm making. Look at all the snow that continues. Check out central Colorado. It is yowzers. Some serious snow there. Got nearly 4 feet of snow still sitting around some areas there. Wyoming also heavy snowpack. Also Montana some heavy snowpack. And let's just briefly switch to precipitation type, since there is some snow falling currently. Also some ice storms likely happening there. That's your precipitation type, one of the many great features of windy.com. Next, your NASA GOES lightning mapper, and some heavy lightning there occurred in the past 10 hours in places like Texas, Oklahoma, Arkansas, and Louisiana especially. Do we have any terrestrial strikes? I think we do. So let's consult lightningmaps.org for a real-time lightning map. Lightningmaps.org, powered by blitzoldung.org. And we've got some lightning here just north of Nolens. We've got a heavy, very active cell there. That's the kind of storm that could be producing damaging winds and hail, possibly even tornadic activity. Check out the lightning strikes. Dag. That is berserk. If you're in the middle of that, please be inside. That is a heavy thunderstorm indeed. And we're going to show you the U.S. Doppler radar and so on. In the meantime, take a moment to press like, press the subscribe button, press share if you're new to the channel, and if you're unwilling or unable to open your cobweb-encrusted wallet, why not help out the channel with clicks? Yeah, that helps us out too. Did you know that? SmashOmash.com is our homepage, and welcome to the Neo-Renaissance. We formed SmashOmash.com in 2019 in response to the pathetic, disgusting, putrid, ridiculous, and nonsensical, and indeed deadly censorship by an organization now known as Meta. Yeah, we watched their stock price crash starting then really in December of 2018 is when we really decided to create our own website, because we saw the writing on the wall. So when you're as far ahead of things as we are, a lot of times people won't believe you. But hey, facts are facts. So if they're making you upset, then we're obviously doing our job, as we are making both sides mad, an indication that we are citing facts and not parroting a bunch of pathetic, stale talking points like so many already ultra-rich famous celebrities who can't get their head out of their you-know-what or get out of their own way. SmashOmash.com. Again, welcome to the Neo-Renaissance. You can find links to the Amazon shop there. We talk about coffee on the channel regularly. If you want to see what I'm drinking today, well, it's right on there. It's the Scandinavian blend 4-pound bag of whole bean Camerons. You can also find the cocoa powder that I drank in my first cup this morning. You can also find other gadgets for your kitchen. Save some cash on bulk spices, and if you want to know some of the supplements that I take, they are found on the Amazon store as well. For instance, every other night I take zinc and magnesium at nighttime, so why not do your Amazon shopping through our store and help support the channel that way? You can also support the channel via subscription services at smashomash.com/smashteam. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security, pathetic, ridiculous social media stockade to the internet underground, where we survive as producers of fortune. If you've got a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you certainly can at smashomash.com/smashteam. Join at the gold or silver level, although we do send out email alerts even to the bronze level Smash Team at smashomash.com/Smash Team. Last but not least, we're going to show you the U.S. Doppler radar map depicted here. And let's briefly zoom in on these strong storms. Quite a bit of red there on the radar. Again, those could be producing damaging wind and hail there at Baton Rouge. Rapidly moving toward Biloxi. Hey, Biloxi, you're in the crosshairs. Let's zoom back out as we don't want this video to be too lengthy to get it onto your screens as promptly as possible. What happened? All right, let's bring up our shortwave radiation map and our water vapor. So there's number one. And here is the water vapor map. We will close things out with these two sets of data. So there is U.S. Doppler radar. There is clouds and fog. And there is water vapor. Hopefully that clears things up. Hopefully you've pressed subscribe and pressed the share button and maybe even left a comment for us here at the Smash News Network, Least Busted Name of News. We do indeed read every comment. And thanks to all of our viewers. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.